Good evening, everyone. My name is Ian Urquhart. I've worn many hats with AWA for quite a few years now. And this evening I get the pleasure of wearing the moderator hat for the fourth in our series of town halls that we've organized on the subject of coal, the exploitation of coal in Alberta. I'm really excited about what's ahead of us this evening in terms of the presentations that we're going to be that we're going to learn from, that we're going to be treated to. Just for those who don't know, a very brief introduction about AWA, about the Alberta Wilderness Association. We are one of this province's oldest conservation organizations, formed around a kitchen table, actually that was within view of the landscapes that really concern us with respect to coal. Formed in the mid-1960s, AWA has been pushing for and advocating for wild spaces since that point in time. Currently, we now have over 7,500 members that you can find in 224-ish communities in Alberta, plus members from outside the province, plus members from outside the country. I just want to let you know as moderator tonight how the procedure for this evening will work. Everyone will be, the audience is all muted. What I would invite you to do is use the chat feature this evening. And one of my tasks as I'm listening to Colton, Mandy, and Bill will be to take down questions that you would like to pose to our presenters this evening. And then once the three presentations are over, somewhere around 7:30, 7:40 in that ballpark, once the presentations are over, then on your behalf, I'll put those questions to the presenters in a question and answer session. As the participants know, this evening's presentation is being recorded, and the video will be put up on AWA's YouTube account. So if you know someone who would have liked to be here this evening but couldn't, please let them know that, and that this evening's town hall will be there for them to view at their leisure. I also tonight wanted to acknowledge that we are on, here in Calgary at any rate, that we are on Treaty 7 lands. Acknowledgement of the land is a traditional custom of Indigenous people when welcoming others to their land and into their homes. Acknowledging the land honors the original people of this territory. And we are here on the traditional territories that have been home to many Indigenous peoples from time immemorial. This evening, I welcome you from this place called Mohkinstsis, the traditional territory of the Blackfoot Confederacy, the Siksika, the Kainai, the Piikani, the Tsuut'ina, the Stoney Nakoda Nation, and Métis Nation, Region 3. We acknowledge these peoples who have lived, worked, played, and stirred this land for centuries. We honor and celebrate these lands, and we also acknowledge the traditional lands from where you may be joining us this evening. As well, I just want to make the point that we share the sorrow from the recent discovery in Kamloops, and hope for the day when that historical wrong and historical wrongs like that one, as well as current injustices, are corrected. As far as the agenda for this evening goes, the presentation list will be Colton Vessey will start the evening off, and Colton will be followed by Mandy Olsgard. And then Dr. Bill Donahue will take us home with the last presentation. I think what I'll do, rather than present all the biographies now, I think I'll just mention Colton's, and then I'll introduce Mandy and introduce Bill later this evening. Colton is a Ph.D. student at the University of Alberta in the Earth and Atmospheric Sciences Department. And Colton has his master's and bachelor's degrees in geological sciences, where he is specialized in environmental geochemistry and mineralogy. And the research that Colton is going to inform us about tonight focuses on contaminants in water systems and mine reclamation strategies. In looking over the CV that Colton sent me earlier today, I just have to tell you how impressed I am to see someone of Colton's youth being as engaged as he has been in community engagement and public outreach over the past while, and I think especially with respect to coal. Colton's been heavily involved in community engagement throughout the province of Alberta regarding open pit coal mining on the eastern slopes. Many citizens, many communities have expressed concerns and asked questions about the protection of the environment, and Colton, through his outreach, has tried to help educate citizens and communities on a range of environmental, economic, and social issues that pertain to open pit coal mining. He's been to the town of Rocky Mountain House to present there, to Fort Saskatchewan, Brazeau County, Clearwater County, the town of Black Diamond. And if we're going to make this place better tomorrow than it is today, I really believe that it's the involvement of youth and people of Colton's generation that's going to be so crucial to make that happen. So with that, I'll turn things over to Colton and look forward to your presentation. Thank you.
Great, yeah, thanks for the warming welcome, and thanks for having me here this evening, and of course a land acknowledgement as well. So I will share my screen to get my presentation going. Okay, yeah, so as Ian pointed out, I'm going to talk about so contaminant mobility and reclamation and what that means in terms of coal mining for historic coal mines in Canada, such as Teck, and also the proposed projects that might come here in Alberta as well. So to start off, I'm just going to briefly talk about environmental geochemistry and mineralogy, like Ian mentioned, was what I study. But I think it's an important place to start because it really targets the fundamental processes that I'm going to be talking about. So what I study, it's a multidisciplinary field which integrates biological, geological, chemical, and physical processes to really understand how natural and also mining systems function. And really what I'm quite interested in is the water, mineral, and microbial interfaces and how they interact. And it's really important to understand those interactions because that's how contaminants are actually controlled in the environment, and particularly in mining systems. And what that means by contaminant mobility is we have to consider all these different conditions, so such as environmental, redox, which is how much oxygen is present, the temperature, the physical conditions, so the physical transport through groundwater of the contaminants, the water chemistry itself, and also the interactions of mineral and microbe surfaces. And really that starts at a really small scale, really at the atomic scale for individual elements. And I kind of show that on the bottom here where we have to consider different processes such as absorption of a variety of ions such as calcium, magnesium, or contaminants like selenium, and also precipitation reactions, and really importantly, the biotic controls, so controlled by organisms and particularly bacteria and microbes, and how they can both enhance and also remove contaminants of concern from the environment. And then once we have a good understanding of that, we start looking at larger scales and transport of contaminants through waste rock material and into natural systems and the physical processes that are involved there. So I'll also talk about the life of the mine briefly. So I think it's important because there's many different stages, and each different stage, usually there's different types of waste produced as well. So it begins with exploration. So there's mapping, drilling, resource estimation, and then if it's feasible, they begin to move forward into baseline studies where they look at the current environment and what it might look like post-mining. Then they move forward into environmental impact assessments and joint review panels, which at provincial and federal levels, where the Grassy Mountain Coal Project currently is at. And then they begin breaking ground, so that involves removing vegetation, so on the far left, and then the topsoil as well. The topsoil they usually store on site because they'll reuse it in the reclamation or remediation plans post-mining. And then next they have to remove overburden. And that's one of the most important parts because the overburden is where a lot of the contaminants are actually held. So when they're undisturbed in geological settings and formations, they're not toxic. There's no concerns typically. But once you move it and disturb it, you change the characteristics of the rock and it can enhance the weathering. So you can release the contaminants such as selenium into waterways and water systems. And then the overburden has to be stored somewhere, and historically or traditionally in open pit mining systems, they push them into waste rock dumps, which then can also be put into valley fills, which is the most common method kind of used for coal mining at least. And then they extract the coal and they have to process it as well on site. So that includes washing it with lots of water, which the water isn't considered contaminated, it has to be stored on site as well. And then once they've extracted all the ore or coal of interest, they begin closing the mine and moving towards reclamation or remediation, which is a long and expensive process as well. So I mentioned what mine drainage is, or what is mine drainage, and where are these contaminants coming from. So I mentioned that there's waste rock dumps full of overburden, and there's certain phases in there that actually release the contaminants, and in particular, it's pyrite or sulfide mineral oxidation. So pyrite is an iron sulfide mineral, and upon oxidation, it can release iron, sulfate, and other toxic metals such as cobalt, copper, cadmium, nickel, and many more, which substitute for iron. And then also arsenic and selenium, which can substitute for sulfur in pyrite structure to very high concentrations. And also with pyrite oxidation and sulfide weathering, you get release of acidity. And if that's acidity, can't be naturally balanced by dissolution of carbonate minerals such as dolomite or calcite or limestone, you generate acid mine drainage or acid rock drainage, which is very low pH conditions. But what we're expecting to see here in Alberta in particular is neutral mine conditions because there is an excess amount of calcium carbonate in the form of limestone and dolomite, which can effectively buffer out any acid generated. But associated with that, though, there is different contaminants such as selenium, which have to be dealt with. And to visualize that, they look very different. So for reference, the pH of drinking water is usually between 5 and 9. Rainwater is around 5.5, depending on where you live. And acid rock drainage has very vibrant colors, so bright oranges, yellows, and reds because of the iron minerals that are present there and associated with the acidity. But in contrast, neutral mine drainage, which is what we're expecting to see and what we do see at the Teck Resources mine in the Elk Valley, is it looks very natural, quite normal. This is the Fording River nearby the Elk Valley, which is very contaminated with selenium and nitrate, and they've had historic issues there, which I'll talk about in a bit. So we also have to consider the groundwater inputs and groundwater flow from these waste rock dumps. The picture on the top right is from Teck Resources of some of their waste rock dumps they have there. And like I mentioned, we have sulfide mineral weathering, which is pyrite. It releases iron, sulfate, and acidity. The iron can precipitate out as iron hydroxides, which can help actually remove some of the contaminants, such as nitrate and selenium, but not all of it, though, of course. And then the acidity in this case is being buffered by carbonate dissolution, so the calcite, dolomite, and limestone, and creating neutral mine drainage conditions. And then we consider the transport of all these ions in solution, so the selenium, and I also included nitrate here because nitrate is the other contaminant of concern, but it isn't sourced from sulfide mineral weathering. It's actually sourced from the explosive used in the mining process. So getting into that, I'll talk about the nitrogen cycle briefly. I think it's important to highlight some of these fundamental processes in order to understand these mining conditions overall, and it'll play into the reclamation or remediation side of things in a minute here. So as I mentioned, the nitrate is actually sourced from what's called ammonium nitrate fuel oil, which is an explosive used to dislodge coal and overburden. And then this can enter the waterways through nitrate directly, and also ammonium through oxidation by nitrification. And nitrogen is really important in all natural systems. It's a fundamental process for organisms, nitrifying bacteria. But when we add anthropogenically sourced nitrogen, such as nitrate and ammonia, in elevated concentrations, it becomes quite toxic. And that's why the water quality guideline for Alberta, and I believe B.C, is around 3 parts per million. So next, selenium cycling. So selenium is a trace nutrient. It's needed by all living organisms in very, very small amounts. And it has its own cycle over here on the right, which I won't go through into too much detail. But more importantly is considering its speciation, or what it does in the water. And that's on the left here. So under oxic conditions where there's lots of oxygen, such as the stream, we expect to see selenate or selenite, which are the most bioavailable toxic forms of selenium in those cases. And then moving down into less oxygen conditions, we see selenium 0, which is typically the target for mining companies during reclamation involving selenium. But if you move past that, you can get into organically complex selenium, and that is also very toxic and bioavailable, and is a major concern. So selenium 0 is really the target, and it forms a nice red precipitate, and it's actually readily reduced by a number of bacteria, which are being utilized in reclamation remediation strategies that I'll talk about. But because it's there's such a small amount between it being a trace nutrient and a contaminant, the water quality guideline is around 2 parts per billion. And in some cases, it's even lower than that. I believe in Montana, they've recently lowered their water quality guidelines to around 0.7 or 0.8 parts per billion. And the reason for that is because of the bioaccumulation in aquatic species, in particular fish, have been really focused on. So you get spinal deformities in fish, and then also facial deformities and missing gill plates and reproductive issues. And one thing that isn't really discussed much is how selenium affects reproduction in mammals and migratory birds. At least it's not really shown as much. But there are some examples out there of this. So this is an example from the United States, I believe in California, where they had selenium runoff from agriculture into a nearby wetland, and they had very elevated selenium concentrations, which affected reproductive issues, or had reproductive issues in migratory birds. And on the right here, we have a deformed embryo with a severe brain protrusion, which is quite graphic, but that's just the reality of contaminated sites like this. So getting into some examples, so Elk Valley, I'm sure many of you have heard about by Teck Resources. They've been around for quite a long time, just over the border of Alberta and near Sparwood. They've been mining since the 1960s. They currently have 4 open pit coal operations, with a 5th one in the proposal right now. And they use the open pit drill and blast method. So they use AMFO, which is the ammonium nitrate fuel oil explosive, and they've had severe water quality issues since the 1980s with selenium exceeding 100 parts per billion. Typically, it's greater than 20, and the water quality guideline is 2. Nitrate and nitrite exceeding 35 parts per million and averaging more around 15 parts per million. And the water quality guideline is 3 parts per million. And then I also included sulfate here. Sulfate isn't really usually viewed as a contaminant, but there are also water quality guidelines for sulfate because it increases the hardness of the water, which affects consumption use in agriculture, plants and organisms living in the water as well. But I think the main bullet point to take away from this slide is the one at the bottom. Some colleagues of mine from the University of Saskatchewan did a number of studies at in waste rock dumps at Elk Valley. And they found that pyrite oxidation, which is the main source of the contaminant release that I mentioned before for selenium and other metals, can occur for up to 300 years post-mining within the waste rock dumps. That's a very long time. And take that with a grain of salt, though, of course, it may decrease over time. It's a maximum value, so it could change depending on remediation strategies, on weathering processes, and also naturally depending on the geochemical conditions. But regardless, though, the pyrite oxidation, if left untreated, can occur for decades post-mining. So what have they been doing to help remediate their current situation since they've had long issues with selenium and nitrate in nearby streams and now in Lake Kukumuska? They have built a full-scale water treatment facility quite a while ago that was initially had some issues, but they've since fixed that and it's fully operational. But what they're hoping to move towards now is using a newer strategy called saturated rock fills or saturated backfills. And they have seen initial success in some of their trials. Essentially what it is they have their open pits and they backfill it with some of the waste rock material, so it helps prevent some of the dumping. And then they pump it with contaminated water. They can either pump it in or passively float through. And then they also have to add chemical nutrients that will then stimulate microbial growth, like I showed earlier. And that can effectively remove selenium and nitrate at pretty good rates. And that you see that on the bottom left, and on the bottom right is one of their full-scale, or was their, I think, first full-scale trial for saturated rock fill at LFU operations. And I believe they are working on scaling up some other ones now. And I mentioned, so they do see some initial success, but that's not to say it's perfect. There is no silver bullet for reclamation or remediation, particularly for selenium or other oxyanions, because they're very difficult to deal with. So this graph shows selenium in parts per billion on the y-axis against time. And these are concentrations for the Fording River. The dots represent measured values and the lines represent predicted values, depending on seasonality. So they do see a decrease from around an average about 40 parts per billion to around 20 moving into the future. But at the same time, though, it's still quite elevated compared to the water quality guideline of around 2 parts per billion. So they won't be able to use this alone and rely on it solely. They'll have to use other techniques and methods, which they are expecting to do. And also more recently, they've seen issues with cobalt and nickel concentrations in the nearby streams, where cobalt has reached 25 and parts per billion, and nickel's reached 140. And cobalt's already exceeding water quality guidelines, and nickel's not far behind it. And tech has recognized that this has had impacts on local microinvertebrate populations. Another thing to consider as well with these saturated rock fills is that they're relatively new. They're 5 to 10 years old. Tech's really been working on it in the context of selenium and nitrate specifically. And studies from the United States have shown that when you open pit mine in an area, you really change how the groundwater and stream flow affect the nearby streams and ecosystems, and you can really increase that. So how will backfilling these open pits with waste rock material change the physical conditions and the groundwater interactions with these streams? And they showed that there's increased base flow or groundwater flow into the nearby areas using these methods. So getting into the Grassy Mountain Coal Project, which is the mine or the proposed project farthest along here in Alberta. It's quite a bit smaller. That's because it's just one mine, around 1,520 hectares, and it does have a historic mining footprint of around 185 hectares, which is one of the reasons they've been using to move this project forward, is because there's historic mining in the area, but it's significantly smaller than the total footprint when all things are considered. But more importantly is what they plan to use for the reclamation or remediation plans. And that's the saturated rock fills that I was talking about for tech. That's been their main driver for their plans. And last I saw, their estimated reclamation costs were around $60 million. That may have changed, and someone can correct me later if that has. And $20 million of that has been budgeted for continued operating costs of these saturated rock fills into the future, because they have to have continual nutrients pumped into the system to actually stimulate the microbial growth to remove the contaminants. There's also a lot of assumptions made in these environmental impact assessments. One of those assumptions is that the saturated rock fills can effectively remove 99% of the selenium within the SRFs. And also that they have to assume a capture efficiency, and that capture, they have to capture all the runoff water that might come in contact with waste rock through a variety of groundwater sources or surface runoff. And changing those assumptions by even a little bit can actually affect the predicted modeling outputs for long-term selenium concentrations into the future. So this graph here is from their geochemistry reports by Benga Mining Limited. The red line is 2 parts per billion, the water quality limit, and the y-axis is in milligrams per liter of selenium. If you multiply that by 1,000, you'll get to parts per billion of selenium. So assuming they can capture 100% of the runoff that's been in contact with waste rock, they will reach predicted concentrations are around 3 parts per billion. At 95%, it's around 6, and then at 80%, it's closer to 13 parts per billion. So changing these parameters can actually quite drastically affect the predicted and long-term selenium concentrations into the future, and that's still assuming that they can remove 99% of the selenium efficiently within the saturated rock fills. Whereas tech usually sees and they assume only 95%, and that seems like a small amount, but over long periods of time, it can add up to a substantial amount. So just some final thoughts. So the saturated rock fills, they're relatively new. The EPA has also released comments about concerns regarding these systems, because there hasn't really been long-term efficiency studies looking at how long they can be managed for, how much nutrients have to be added, and for how long. So that's one big concern. And then how have the assumptions for the environmental impact assessment affected the Grassy Mountain coal project to move forward? In particular, their removal and capture efficiencies, and then also have reclamation costs been underestimated? That's a difficult question to answer because every site's different, and different operating costs and also maintenance costs. But in Alberta here, the Alberta Energy Regulator allows for self determination of reclamation costs, which may also be an issue depending on the company. And then just a last thought, there are many implications for open pit mining in general, and especially coal mining in the Rocky Mountains. There's many topics that could be covered, and I think the AWA has done a great job of touching on many of these. And yeah, with that, I'll end my presentation, and thank you for your time, and thank you for having me.
Colton, thank you very much for that presentation. Before this evening, I realized that selenium, it's hard not to follow coal and not to appreciate that selenium has been an issue in the Elk Valley. But until this evening, I didn't realize the scale of the problem, in the sense of just how elevated selenium levels are relative to water quality guidelines, and it does send a shiver down my spine when I look at the numbers that are reported for nitrates and selenium in the Elk Valley operation. So thank you very much for that. And I think now we'll shift over to Mandy Olsgard, and Mandy and Dr. Bill Donahue will focus more more specifically, I suppose, on the regulatory system itself. You know, the Minister of Environment here in Alberta, Minister Nixon, has advertised the Alberta regulatory system, environmental regulatory system, as, in his words, robust. And so, given what Colton has introduced us to this evening, to what extent is the province doing a good job, if you like, when it comes to regulating the types of toxins and chemicals that Colton identifies? And Mandy's going to take the first look at this through a case study that she's done of another Teck operation. That's Teck's Cardinal River operations. Mandy is, I will digress for a minute. One of the really great things about this issue that so upsets us is the opportunities it's given us to meet other people. And so meeting Colton, Mandy, and Bill Donahue tonight is a real bonus from the madness that afflicts politicians in this province. And so it's been a real pleasure to meet Mandy and learn from her as part of this issue. Mandy is currently the owner and senior toxicologist at Integrated Toxicology Solutions here in Alberta. In the past 15 years, Mandy has worked as a toxicologist and a risk assessor in research, consulting, and regulatory environments to develop effective and coordinated risk management plans for energy and non-energy resources by collaboratively addressing industry, regulatory, First Nation, public stakeholder concerns. The focus on Mandy's career to this point in time has been on researching and developing methods to understand the toxicity of environmental contaminants that are released from conventional and non-conventional oil and gas, mining, municipal governments, and what impacts they have on environmental and human health. She's done this through the work that she's doing now. She's done this through the work that she did previously with the Alberta Energy Regulator. And she provides the technical expertise on regulatory application reviews, regulatory hearings, and through her own independent research that hopefully will improve our ability to deal with these pressing problems. So with that, Mandy, I'll turn the screen over to you and take us away to Teck in the Cardinal River.
Thanks, Ian, and great presentation, Colton. I'll just share my screen here. Oh, there we go. Okay, so as Ian said, I'm going to talk a little bit about what I found when I dug into some of the government and industry materials for the Cardinal River operations in Alberta. I will caveat this that almost everything you're going to see on the screens tonight, I've taken directly from industry reports or regulatory agency publications and government policy documents, but the interpretation and conclusions that I'll present are my own and based on my own professional opinion. So just a really quick overview of regulation of coal mining in Alberta. So that is the responsibility of the Alberta Energy Regulator under the Responsible Energy Development Act, which stood the regulator up in 2013. So under this act, the Coal Conservation Act, APIA, so the Environmental Protection and Enhancement Act, Mines and Minerals Part 8, Public Lands Act, and the Water Act came under the mandate of the Alberta Energy Regulator. So the Alberta Energy Regulator, the AER, they do regulate using the policy direction set out by the Alberta government. And I'm sure Bill could provide some thoughts on the process, but I'm just going to very briefly go through the steps and the information I pulled from each of these. So you have environmental assessments, as Colton spoke to. So that's generally where you see the environmental impact assessment that's submitted, where they'll identify potential impacts from the development and the plan for how they'll mitigate or manage those impacts and move through to reclamation. After the EIA is submitted, a fairly long process actually, there will be a public interest decision by the board. For large scale mines like this, that generally follows a hearing. And the public interest decision, again, as Colton said, that could be the provincial government, or it could be a joint review panel, which would be the federal and provincial government. Then the AER will issue an approval that outlines the conditions under which the proponent or the industry partner operate. And it's really these conditions that are laid out in the approval. What I'll be talking about specifically tonight is that APEA approval, the Environmental Protection Enhancement Act. And that's how we ensure that these mines are in compliance. So the Cardinal River operations is actually intriguing, trying to follow the development of these mines and just how many different mines there have been operational and the owners. When I first tried to find the environmental impact assessments, there was 3 submitted. None of them are available on the Alberta government's website. So I couldn't really dig into the EIA and understand what impacts they predicted. So I had to use the statements by the panel. And so, I think it's important to recognize that most of the decisions that are made have an economic analysis behind them, and a risk-benefit analysis has been completed. And so the Cheviot project, the Cardinal River coals, provided, they concluded that underground mining wasn't economically feasible. And that's why we end up with these open pit mines. So there was a joint panel, and the decision was published by the joint panel. So once the EIA was approved and a decision came down, there's the APEA approval that was issued by, in this time, the first one was from the Alberta government, and then like I said, so the Cardinal River operations, sorry, there is an annual report that's submitted by industry every year, and you can see all the appendices here. These are many of the biophysical components that are required as part of the management plans that were submitted once the mine became operational. So you have some dedicated to Grizzly Bears, selenium monitoring, Harlequin ducks. So generally they're trying to monitor and understand if the impacts they predicted in the EIA stage became measured impacts on the landscape. I accessed all of the information through the AER's Information Distribution Services portal, and I put that there because none of the industry reports I just showed are available through an open data access portal the AER offers. You have to request them and pay for them, and then they'll be provided to you. So there's the information if anyone's interested in getting some of the reports that I'll talk about today. So with respect to selenium, so there was a decision by the panel acknowledging that selenium levels in the aquatic environment could result in impacts to fish and fish habitat. But they did not think it would be a significant risk of adverse effects on regional water quality. And I think that the language that they used here is very important. So it was well understood that there will be impacts on the local water quality, but not regional. So when the APEA approval was issued, they recognized that selenium contamination off-site in the McLeod watershed was going to be an issue, and they had to come up with a comprehensive monitoring and evaluation plan. So that's over here in clause 2.6.2. Then along with that, you have the objectives that the proponent, so Teck, who took over the Cardinal River operations, they have to try and meet those objectives in the ambient environment. And so you can see there's 4 monitoring locations. These are all in the ambient environment. These are not on site. These are not in their holding ponds or their groundwater directly beneath. These are in the ambient environment where you have fish living, birds drinking, living, all these types of things happening. So these targets and triggers will come important on the next page. So what I did was I requested those 2019 monitoring reports. So we're talking, 2 years ago now, but you report a year after you do your monitoring. And so when we look and we try and understand if they're meeting those REACH specific objectives, it was actually easier to highlight when they were compliant. So you can see in the green, in these green highlighted sections, this was the only measured concentrations that were below the REACH specific objectives that the regulator had identified to try and manage selenium contamination. So, they do have trends. They have 5 and 3 year trends. Generally, it's increasing, right? And it's increasing further downstream, which is concerning. So these plumes are moving downstream, and they have increasing trends in 2019. So they've been managing selenium contamination on this site for a decade, and we're still seeing increasing trends. Additionally, when we compare those concentrations to the guidelines in Alberta, so that 2 micrograms per liter is the guideline, 1 microgram per liter is the alert concentration, you just see consistently they're exceeding the Alberta surface water quality guidelines for the protection of aquatic life in the ambient environment. And these reports are really important, I think, for scientific audiences and the public to be reviewing. Like in this report, the consultants who work for tech identified that it was the tech operations that were elevating selenium in the environment. It wasn't natural, it wasn't in this system. These are increasing trends over time, and they know exactly where it's originating from on site. But rather than have some sort of management strategy, we're looking at, they propose to continue to monitor the situation like they've done for quite a long time. And I think Bill will talk about the selenium contamination issue a little bit more, but it's not just I'll just quickly say, there is a risk assessment and risk management component to this. Risk assessment is generally predictive. So I thought this was a bit odd to see in the report. So they said, we'll keep monitoring the issue, we'll update the risk assessment. But again, they're measuring concentrations in the environment that are over the Alberta surface water quality guideline. And so, risk assessment in this case really isn't a solution for addressing environmental problems. Likely they need to be moving on to mitigation and management. So again, I think the solutions that are being proposed aren't reflecting the risks in the environment that are measured. And it does make one question about whether the selenium that's coming off the Cardinal River operations is, deposition of a deleterious substance, as we just saw at the Elk Valley, one of the largest fines historically for, non-compliance. Again, it's not a one-off situation. Harlequin ducks were identified as a vector of concern in the EIA. They did predict that they would be impacting Harlequin ducks. You can see under number 16 here, the panel concluded that there would be some adverse effects. However, the mitigation that the proponent at the time proposed is sufficient to mitigate these adverse effects, and they would be insignificant. So again, we see an APIA approval clause that's trying to address the impact that was identified and measure whether that impact became real and on the landscape. So when we look at the report, it was quite striking, actually. They've been seeing significant declines in Harlequin duck populations over the past 24 years. And I think this report was important because these are significant declines, right? If we look at the figure on the left in the pre or early mining, and I call it early mining because, there would have been some disturbance of the area when they were exploring or previous operations, but there was no significant decreases in those populations. And again, these are for the female Harlequin ducks, but the report goes through males and ducklings and all the other population dynamics that they're measuring. Okay, so then when we look at the females over time, significant decreases. So I would argue that the impacts that were predicted are not being managed through that APIA approval clause, and they are not in compliance. There needs to be some other action, some other mitigation to protect these Harlequin ducks. Sorry. So as I said, I think significance is important when they were looking at the broods, so the number of ducklings per year. You know, it looked like there could have been decreases happening over time in those pre or early years, but it was insignificant. But post-mining, we see that decrease become significant. So again, this is a change. And when you read the report, this is, I don't think they acknowledge that there is a significant decline in number of ducklings per year. So again, impacts at a population level in these Harlequin ducks. Grizzly bears were identified as another sensitive receptor that could be impacted by the mining operations. So we see an APIA approval clause for the proponent to participate in regional monitoring and management initiatives. And so when I looked at the Cardinal River reporting for 2019 and all the additional information that was provided, it does seem like they've really tried to understand the grizzly bear population, and they have really mitigated and manage impacts to the grizzly bear population, and we don't see any. This was a regional initiative. There's a lot of academics involved. There's a lot of stakeholders involved, and I think that speaks to the success of maybe this specific APIA approval clause and the protection of grizzly bears. I did think it was interesting in the APIA approval that there are no clauses around the protection of Aboriginal rights, Indigenous rights, traditional or human health. So the Alberta Energy Regulator does not have a mandate to regulate to protect human health. But when you look at some of the reports, you can see that traditional foods or culturally important species, you know, they're being observed on the mine sites where we see some of these contaminants being liberated into the environment in more bioavailable forms, you know, that could be increasing tissue residue levels, it could be impacting the health. This was acknowledged in the panel's statement, but again, it's out of the jurisdiction of the AAR. So we don't actually see risks to First Nations and Indigenous communities being managed. The AAR has a compliance and enforcement portal that you can click on. I have the dashboard link down here. And so I was interested in reading these reports to see, so when I'm noting these potential non-compliances and I'm seeing that the APIA approval clauses, you know, whether they're being enforced properly or there's management decisions being made, I don't know. But when I went on the portal, there's no mention of any of these potential non-compliances. So that selenium being over those trigger limits that were identified in the table. So, you know, there's values and I think quantitative assessments we could be using to understand if there's non-compliances, but I couldn't find any on the portal. So my conclusions, this was a bit of a larger presentation that I'd given, but, you know, I do feel that the decisions are being made because of economic pressures and they're driving these systemic issues in the Alberta regulatory system. So until you can disentangle the AER from industry and we can make, you know, really clearly do those economic, environmental risk benefit analyses and transparently report those out, I think that economic pressures are a risk to environmental protection. We have systemic issues which are limiting environmental protection. We see these in the board decisions. Again, you know, the AAR is part of the board making the decision. The federal government is sometime present. I think I clearly showed that economics are driving the decisions, not environmental protection. We see the approval clauses, compliance and enforcement. I couldn't find any compliance and enforcement actions. I think if we could have those benefit liability analyses being, you know, quantitative, predictive and forward-looking, if they could accompany regulatory decisions so that all stakeholders could understand why and how decisions were made to approve these projects, that would move the system forward, and they have to be publicly released. And again, I do acknowledge that this may be the cost of doing business, but we have to, on the other hand, acknowledge that it's not entirely world-class, it's not risk-based, and it's not in a balanced approach in Alberta. And I guess we're going to hold questions to the end. So,
Mandy, thank you. Thank you very much for that analysis. I mean, as one of the things you said that really strikes I'm a recovering political scientist, but I'm still a social scientist, and I think one of the things that really strikes me from your study is how the possibility of the involvement of other stakeholders and how important that may have been in terms of the actions that were taken vis-a-vis grizzly bears relative to the other subjects that you studied in this particular case, and that those economic pressures that you're referring to and their importance would seem to be magnified in situations where there aren't those other stakeholders, where there aren't others to speak up on behalf of Harlequin ducks or speak up on behalf of grizzly bears, that in the absence of those interests, then the economic pressures probably easily prevail in that environment. So and as well, I was going to ask a question about what can you say about the compliance and enforcement actions? Well, I think you did, which was you couldn't find any. With respect to lack of compliance and what enforcement may have been taken. So anyways, much there to think about. Thank you. Thanks again for that. All right, so our last presentation tonight comes from Dr. Bill Donahue. Bill is now living out on Vancouver Island, where he's an independent environmental researcher, strategic advisor for industry, for government, community, Aboriginal and university clients. Since the beginning of this century, Bill has focused on developing practical science and policy recommendations and solutions to large-scale environmental problems that are associated with our expanding human footprint on the land and the changes in land use that result from that. Cumulative industrial effects, climate change, drought, impairment of freshwater systems. A long time ago now, I remember reading one of Bill's papers about climate change and the Athabasca River and what was happening to glaciers and what the impacts are going to be for the future of that particular ecosystem. One of the things that, and I'm sure I don't know if Dr. Schindler was a mentor of Bill or not, but I'm sure one of the things that David Schindler would really appreciate about your work, in addition to its thoroughness, is your willingness to critique environmental policy and management in Alberta. From 2015 to 2019, Dr. Donahue worked for the government of Alberta. He was Alberta's chief monitoring officer. He was the executive director of both monitoring and science in Alberta Environment and Parks. He resigned, though, because of consistent cuts to environmental monitoring at the provincial level, to persistent cuts to science programs, and persistent cuts to budgets. As a former lawyer, Bill also has a Bachelor of Laws degree. He was also Director of Policy and Science for an environmental non-governmental organization here in Alberta. He's now been analyzing, since early this year, Alberta Environment's water quality data from monitoring performed both upstream and downstream of the mines, of the operations that Mandy was talking about earlier, and that in the tech operations in the Cardinal River area. So with that, Bill, please take it away and let us know what your view of this robust regulatory system looks like. Thanks.
Thank you, Ian. I'm in response to your query or your wondering, actually, I did my PhD with Dave Schindler and worked quite closely with him, and he was actually my co-author on that climate impacts paper from 2006. So tonight, I'm going to talk a little bit about some analyses of Alberta environment monitoring data that were collected between 1998 and 2016, upstream and downstream of 3 coal mines south of Hinton. The Olsgard mine, the Greg River mine, and the Cheviot mine later. And I'll describe a little bit about kind of what some of the impacts are. This is really a kind of an overview. It's not an analysis of all of the data. I've looked at data that were samples that were collected on the same day, upstream and downstream of each of these mines. And in that way, I can look at sort of effectively interpret what the impacts of the mines are on these rivers or streams. So we'll look into, we've heard a lot from the Alberta government recently about the promise of coal, and including that, you know, from the Minister of Energy recently when she announced that they were stopping further lease sales and struck a panel to hear the concerns. She encouraged people to have faith in Alberta's regulatory agency and the monitoring programs, and then also referred to the stringent environmental protections. Mandy went a little bit into the regulatory practices, and I'll be describing a taste of, I think, what's on the monitoring side. So here's where we're talking about in the province: Olsgard Creek, the headwaters of the McLeod River, and Greg River. All of these are in the headwaters of the McLeod River watershed. The mines had reference sites upstream of them on these different water systems that were used as references, as I said, and then immediately downstream to look at water quality impacts caused by the mines. The Greg River mine started operations in 1969. The Olsgard started in 1982, or actually other way around, Olsgard 69, Greg River 1982. Greg River ceased operations in 2000 and Olsgard in 2003, 2004. However, Olsgard's mine processing plant and site remained in operation for processing coal from the Cheviot mine, which began operations in 2005. It shut down in 2016, about the time that these monitoring programs were terminated because of budget cuts in Alberta environment. By the end of that period, 2017, 60% of the Olsgard mine was reclaimed, 53 square kilometers of the mine site were reclaimed, 60%. And 99% of Greg River's 37 square kilometers were reclaimed. However, neither of those had been certified as reclaimed by the AER. So here's a busy slide. Each of these graphs, each of these lines, red, blue, and gray, are for the different mines, upstream and down, and each of the sets of bars are for different water chemistry parameters. Essentially, what these show are the ratio of downstream concentrations divided by upstream concentrations. You can see it's an exponential scale. So where the bars are greater than 1, that's the number of times higher the concentrations are downstream of the mines compared to upstream. And so if it's greater than that, it's higher. If it's less than 1, it means concentrations have declined. And the stars just indicate all of these are significant other than where the stars are. And so you go through these, and there's a lot of significant impacts, and a lot of the different chemicals. Colton talked about a few of them that are associated with coal mining. These sorts of things are seen around the world in response to coal mining, downstream of coal mines. A lot of basic water chemistry quality parameters increased. Turbidity, which is kind of a measure of the amount of suspended sediments, is sort of how, you know, murky the water is. It increased 3 to 12 times between these 3 different mines. Temperatures increased by between 1.7 and 4.3 degrees. Nitrogen, mostly nitrate, as Colton described, increased by 5 to 38 times on average. Chlorine, 3 to 31 times. A lot of heavy metals demonstrated substantial downstream increases, such as 7 to 8 time increase for arsenic, 6 to 14 times increase for selenium, 5 to 26 times higher for lead, 14 to 50 times higher for antimony, 13 to 50 times higher for manganese. And I'm sure you all can't read it, but cobalt, which Colton mentioned, is the one with the highest bars on the far left. Then there were a variety of other compounds, chemicals, cations, such as sodium, and that's of particular interest, as I'll talk about, in relation to irrigation water quality. And on average, sodium concentrations increased between 8 and 80 times downstream of the mines. So this is just a tabular form of some of those. So as you can see, cobalt in Olsgard Creek increased by 350 times. Generally, the numbers were less for Cheviot than the other 2 mines, but keep in mind, Cheviot had only been operating a handful of years and was kind of increasing where the other 2 had operated for decades. And however, noting that Olsgard and Greg River for most of this period had actually been shut down and were arguably being reclaimed or were substantially reclaimed. So I'll leap right into selenium, since that seems to attract the most attention. Elevated concentrations and frequency of exceedances of the provincial water quality guidelines in samples from the undisturbed upstream reference sites, which are in blue, show that these systems may be naturally high in selenium. So the lower red line is what's considered to be the alert level for selenium at 1 part per billion, or 1 microgram per liter. And the upper red line is the protection of aquatic life limit for selenium at 2 micrograms per liter. So as you can see, the blue circles are Olsgard Creek. A lot of points are actually above that protection of aquatic life limit for the undisturbed creek. And it's not really that surprising. These mines aren't located randomly on the landscape. They're located where there's coal, and where there's surficial and subsurficial coal, and creeks are flowing through them. It's not unreasonable to expect that the concentrations of some of these compounds will be higher than in areas where that geology is not present. But what's obvious is that there is no disputing that coal mining has increased selenium concentrations in each of these creeks or rivers. And it didn't really matter whether the mine was closed, such as Greg River and Olsgard, and purportedly substantially reclaimed, or if it was newly opened like Cheviot. The selenium concentrations downstream in Greg River and Olsgard Creek remained unchanged. There was no statistical change throughout this period, despite that they were closed and being reclaimed. And meanwhile, in Cheviot, which are the red triangles, the concentrations of selenium began to increase pretty much immediately after it began operations. And I'll point out also at the top of the graph, there are actually irrigation and livestock limits for selenium as well. Now, irrigation, of course, is of no relevance in the upper McLeod River watershed, which is part of the Athabasca. But if these mines, or if these sorts of changes in water chemistry occur in southern Alberta, such as the headwaters of the Oldman River, below which there's substantial irrigation agriculture and a lot of livestock operations, well, then maybe it becomes more of a concern. Maximum concentrations in selenium were over 40 micrograms per liter in Olsgard Creek, almost 12 in Greg River, and 6.2 in the McLeod River. So far higher than the the limit that's been identified and adopted in Alberta for the protection of aquatic life, which is 2 micrograms per liter. Oh. So here's an example of some of the exceedances of the water quality standards. And this isn't all of them, but the general pattern, as you can see, for selenium, chlorine, and aluminum, is the downstream of the mines, each of these mines, there are substantially more frequent exceedances of these limits or standards for water quality. Selenium, effectively all of the samples downstream of the Greg River and Lusgar mines exceeded that 2 microgram per liter level that is needed to protect aquatic life. Substantially fewer samples upstream exceeded, but as I explained, and as you could see in the graphs, in Lusgar, it was higher than in the other ones. Cheviot, of course, you know, lower frequency of exceedances of the 2 levels, the alert level and the protection of aquatic life level, than in Lusgar and Greg River, but the reference system had 0 exceedances of those limits. And to kind of touch on what Mandy had talked about regulatory and management responses, the alert level is actually supposed to trigger increased monitoring, increased study, a management or regulatory response, including studying these systems to figure out what exactly is going on and to identify options for management and regulation that will prevent concentrations from exceeding the levels that will become a hazard to aquatic life. That said, I mean, you know, as we can see, these numbers, these selenium concentrations absolutely blow away that protection of aquatic life limit. So the question remains sort of what has been done in response. Similar patterns for chlorine, upstream, downstream, big increases downstream relative to upstream, and then aluminum as well, both at chronic and acute levels. And then others at much lower frequencies. And I'm just showing sodium because I'll get into it when it becomes relevant in relation to irrigation water quality. Similar to selenium, similar to many of the metals, you can see that the mines result in a huge increase in sodium concentrations downstream in these systems, and that natural concentrations are quite low. So the sodium absorption ratio, I'll talk about that because it's important as an irrigation water quality standard. Now, it's simply a ratio of the concentrations of sodium by, you know, a manipulation of concentrations of calcium and magnesium. And what it means is that essentially, if the balance between sodium and calcium and magnesium is upset, sodium increases at a rate that's higher than changes in calcium and magnesium, then the sodium absorption ratio increases. Alberta Environment's water quality standards for the SAR, basically, if this number is less than 5, it's safe for irrigation use. If the number is greater than 10, it's hazardous for irrigation use. If it's between those 2 levels, it's considered possibly safe for irrigation purposes, which I find to be rather interesting as a term of use, to be something to be possibly safe when it comes to risks, as opposed to possibly hazardous. People don't typically say, you know, oh, go ahead and take that drug, it's possibly safe. So when you look at the SAR for these systems, you can see upstream of the 3 systems, it's substantially higher than, or substantially lower than downstream. So downstream, it increases the sodium absorption rate. For Lusgar, you know, a lot of the samples were into the possibly safe or possibly hazardous range. For Greg River, they didn't get up into that range, but they substantially increased above the effectively 0 or slightly above 0 values for sodium absorption rate. And then for Cheviot, similar increases were seen, not to the same scale as the other ones, but over time, though, that ratio was increasing. So in Lusgar, the absolute increase on average was 5.4 units, which of course means the average increase was high enough to shift it into possibly hazardous for irrigation use. For Greg River, the average increase was 2, and then for Cheviot, 0.8, although increasing over time. Conductivity, specific conductivity is also used to indicate irrigation water quality. And similar to the SAR, if it's less than the unit, 1,000 microsiemens per centimeter, it's considered safe. If it's greater than or equal to 2,000, then it's hazardous. And if it's between, it's possibly safe, or I would argue possibly hazardous. So similar to the SAR, you see shifts of substantial numbers of the samples into the potentially hazardous range in Olsgard Creek downstream of the mine. Actually occurrences of impaired or potentially impaired irrigation water quality downstream of Greg, and increases in the average ratios in Cheviot, not above that threshold of 1,000 microsiemens per liter. So on average in Olsgard, conductance increased by 82% for over 400 units. Greg River by 94%, 348 units, and then by Cheviot Mine, 32%. So what's that mean? Well, for conductance, it meant that there was a shift to potentially hazardous 54% of the time downstream of the Olsgard mine, and potentially hazardous 8% of the time downstream of the Greg mine, as indicated by conductance. And then by the SAR, similar patterns. Downstream of the Olsgard, 61% of the time, the water quality would have been considered potentially hazardous for irrigation use. As I said, this isn't of real relevance in the Upper Athabasca, but if similar declines in water quality from the perspective of irrigation potential occurred in the headwaters of the Old Man River because of expanded or new coal mining activities there, what then are the implications downstream for irrigation districts and farmers relying on these waters for irrigation? Good question. I'm not an expert in this. These are just the data as they show, but certainly the people in Southern Alberta would be able to speak to these sorts of risks. Recently in the news, there have been a couple of articles describing the potential to mitigate some of these harms by using such things as in-pit lakes. And one example that came up in an article sort of minimizing the potential risks for expanded coal mine was in relation to a lake called Sphinx Lake, or an in-pit lake called Sphinx Lake, which was former Olsgard Mine Pit 51 C6. Now, it was constructed by replacing and reshaping material removed from the pit. They backfilled it and then filled it with water. They then kind of reconnected Olsgard, or a Sphinx Creek, to the top and the bottom of the mine pit. It had previously, during operations, been rooted around. And then that creek was to serve upstream as spawning and rear streams for fish. Now, these are quotes from Tech's website. We've watched over the years as Sphinx Lake has flourished, and today it meets all the criteria for ecologically healthy lake. Well, not entirely. At least 5 years after it was established, and a year after the ACR, Alberta Chamber of Resources, gave it an award for reclamation. The company's employees and contractors reported that all measured water quality parameters for which there were federal guidelines were below those guidelines except for selenium, which was still almost 3 times higher than what was required to protect aquatic life. And still at that time, in 2008, downstream of Olsgard Creek and Sphinx Lake, the concentrations in Olsgard Creek downstream of the mine were still 20 micrograms per liter, 10 times higher than those limits, and remained high at that level until 2016, when monitoring was terminated. Independent studies by people at University of Lethbridge looked at 5 mine-affected streams in the Upper McLeod, including Olsgard and Sphinx Creeks, downstream of the reclaimed mine and the N-pit lake. And they saw significant declines in invertebrate communities, diversity and abundance. Mayflies, caddisflies, and stoneflies, as any fly fisherman will know, are important prey species, but also really important for assessing toxicological impacts and changes in water quality as a result of point sources. Significant increases in selenium concentrations were observed at every level of the aquatic food chain, from water, biofilm, invertebrates, and trout mussel. And they observed up to 97% reduction in total rainbow trout biomass in these mine-affected streams that could only be explained via its relationship to selenium exposure. And no other habitat or water quality variable that they considered and looked at, and they looked at a lot, could explain that reduction in fish populations. A subsequent study also looking specifically at these end-pit lakes in the upper McLeod concluded that they are not suitable for management as recreational put and take fisheries because of the high selenium exposure in these end-pit lakes under current mining and reclamation strategies. And they then went on to say that while they may be suitable for growing and stocking fish, they may pose a significant problem for managers because selenium that bioaccumulates in the tissue may exceed guidelines for human consumption and pose a hazard to wild vertebrate predators. So, what we've seen, I think, at these three mines in headwaters, they've caused clear long-term harm to downstream aquatic ecosystems. They've increased biological and ecological hazardous levels almost immediately after the opening of Cheviot Mine, during the operation of all three mines, and for almost 2 decades of sampling after the closure and during reclamation. Declines in these qualities have resulted in huge declines in rainbow trout because of selenium exposure. And these, as I said, are effects that have been reported around the world. They've included in the US, Australia, China, Europe, B.C, pretty much anywhere where there's coal mining. So I think they should be of great concern to anybody who is considering the impacts in the southern foothills. Now I'll just pop these up in for you. This is the entirety of the coal royalties in Alberta for 5 recent years. This is not going to be a financial savior for Alberta. Interestingly, none of the totals for the annual royalties from coal is as much as Jason Kenney's Energy War Room budget. And yet all of those numbers are far more than the current provincial tributary monitoring budget, which is 0. So Minister Savage, when she says trust the monitoring and the regulatory regime, I'd say that's a questionable statement.
Bill, thank you. Bit of negative thinking there at the end, though, Bill. I was a bit disappointed, when you brought up that royalties thing. $0 for tributary monitoring. I mean, come on. But it does. But what's shocking about all of this, or should be shocking about all of this, is that it really seems that when I listen to you and when I listen to Mandy, and when I look at what's happened in British Columbia, as Colton points out in the Elk Valley, the response of the regulatory system to this harm seems to be like, so what? Like really, I mean, so what? I mean, we're not able to identify compliance actions. We're not, with the exception, as Mandy pointed out, of the fine that Teck was levied recently for its Elk River or for its Elk Valley operations. But when we look for the, where's the record of compliance and enforcement? It's just not, it's just not there. And, someone more cynical than I might believe that when we see the absence of monitoring and the cuts and the elimination of monitoring budgets, that's being done because there's not a happy story to tell, and we don't want to tell unhappy stories with this. I have some questions for everyone, And so it's 10 to 8 now. I'm wondering if we can maybe keep you till, no later than say 8:15 is what we'll shoot for tonight. So this is a question I think for all of you, and it comes from the substance of all your presentations. And with respect to a human constituency and with respect to a non-human constituency, when we think about these contaminants in the context of Southern Alberta and what that future could look like, who would be the human constituency that the three of you think should be most concerned about coal along the eastern slopes from the water quality perspective? And from the non-human perspective, what would be the constituency you think that's most at risk about this? So Colton, maybe could we start with you? I mean, what would your views be on that?
Yeah, so I mean, yeah, Bill kind of touched on that a little bit, like downstream implications. And it's really hard to quantify that, especially when these mines haven't moved forward yet. Tech is so large in the Elk Valley that they've been there for so long. That's why they're having really awful issues with their selenium and nitrate contamination moving down into the Montana as well. But in terms of what we might expect here in Alberta, it's difficult to say if one mine might have an impact and how far of an impact it might have. Well, I shouldn't say if, but more so how far it will have an impact. In the local tributaries right beside the Grass Mountain Coal Project, there's the Gold and Blair Creeks, which are two very small tributaries, which are essential for some of the native cutthroat trout populations in the area. Right. And even their geochemistry reports have shown that concentrations will exceed water quality limits at some point in time during operations and post-mining, with a lot of the assumptions that have to go behind the scenes. But in terms of agriculture and how far down it goes, I think that's really difficult to say at this point.
Yeah. Okay. Mandy, what would your thoughts be about that?
Yeah, similar to Colton, I think this is, short term, years to decades, it's a local issue, and it's going to be those cutthroat trout populations, the anglers that rely on those populations for recreation, but also livelihoods, right? Like it might not be the economic benefits to the scale that industry is talking about, but these are people's livelihoods, right? So those local and those creeks like Honeymoon Creek and some of those areas that we're looking at that are just pristine, right? I think we've talked a lot about selenium and the reclamation issues. Operational mines, I think air quality is a huge issue. So deposition of contaminants from the coal mine dust into those systems. And I really think that the impacts to the grazing pastures along the eastern slopes. And so no, we don't talk about the operational aspect a lot because we really are trying to manage this risk before it even becomes approved, right? But I really think operationally that air quality and those dust impacts and then the local creeks and environments. And then to Colton's point, I think longer term, it is irrigation in those downstream users, but we are talking quite long term, right? That post 20, 30, 40 years from what we've seen from, Tech, Elk Valley, and then the Alberta operation. So I think it's about, spatial and temporal scale and understanding who the stakeholders are, the constituents in each area. There's just different risks.
Okay, thanks. Bill?
Unmute myself. In terms of the human constituency, I'd say the ones that, kind of a crass term, but I'd say First Nations, certainly, not only in relation to treaty and constitutional rights, but I'd say the connection to wild lands. We're talking about areas of the province and ecosystems that are relatively undisturbed. And so I'd say anybody who values those inherently, believes in environmental protection or that environmental sustainability should be occurring, or even more selfishly say, are wanting to go to and use those areas for their own purposes, whether it's fly fishermen or hikers or whatever. I mean, no one wants to go hike and fish in the middle of a valley that's been ripped apart by a coal mine. Ecologically, coal mining is an absolute disaster in pretty much every way. Whether it's the downstream aquatic effects, whether it's the land use, landscape scale effects, whether it's the air quality effects. So it's hard to pick one. In terms of the real legal levers, I think of the Fisheries Act and the prohibition against deleterious substances and the destruction of fish habitat. And it's undeniable. It's absolutely undeniable that is occurring in Alberta. That study I described by Joe Rasmussen and Catherine Kachapsky from University of Lethbridge, simultaneous with the sampling going on in the Upper McLeod, they actually did the same sampling in the Elk River, and they identified exactly the same changes and patterns of changes in invertebrate communities and everything else. So, this is not unique. What's happened in Elk River is not unique to there. It's not as if you cross the Great Divide and physics and chemistry stops working. It's happening in Alberta. Where is DFO? Where are the feds in terms of regulation? We have environmental laws and strong prohibitions in the Fisheries Act for a reason. Canadians have decided that these things are important. So, sure, it's very subjective, but as a rule of law kind of guy, I think that the feds are completely abdicating their responsibility. I mean, I don't know that you can abdicate your legal responsibility to protect the environment, but it's effectively they're asleep at the switch at the least.
Yeah. Was it there's a question about a budget for water monitoring bill, and can you take this one? I mean, was there a time when you would regard, say, the Alberta Environment and Parks budget for water monitoring as being significant and or reasonable?
Short answer, no.
Mm-hmm.
It cycles between, I'd say, the amount of public heat they get. There have been times, I remember, in the early 2000s when effectively monitoring stopped. I mean, people were told there's not money to put gas in your vehicles or your boats. So while we haven't closed the programs down, there's no money. Aquatic monitoring budgets for the entire province were on the order of a few $100,000. When everything blew up, when Dave Schindler and Eric Kelly published those papers in the oil sands monitoring, the demonstrated Alberta environment and the regulators were completely dropping the ball with this industry self-monitoring approach. A regime was set up to charge the oil industry $50 million a year, and legitimate monitoring was built largely under the leadership of Environment Canada. And then subsequently things started changing in the province also. But, in the last 5 years, both of those have been substantially hit by changes in governance and an increasing control by the same old people in Alberta environment and industry and in the regulators who seem to think that monitoring is too expensive and it's dangerous because it arms people with information that allows them to question the party line. So, we've seen cuts to budgets. I resigned because of cuts to budgets. There were consistently cuts to budgets each year. And this was just within a year or two of the establishment of an independent agency for monitoring because of the clear either inability or unwillingness of Alberta Environment to do it properly. So, these cycles change as frequently as the political winds.
Uh-huh.
Unfortunately, and in the reviews that were made, one of the things they highlighted was that there needed to be secure and stable funding that was immune from departmental or political interference. That was one of the recommendations that wasn't followed when they set up the agency.
And one of the messages that comes out of you, I think you used the word transparency, but one of the messages that comes out of this, or maybe you said, an informed public, words along that line. One of the outstanding features of this type of regulation in Alberta, Mandy alluded to it as well, is just how difficult it is to get information. or how expensive it is to get information, and should the public have to pay the sorts of fees that they have to pay in order to, in order to try to inform themselves about something that matters to them.
Yeah, and it used to be, it's become more difficult to get that information. If you look at the AR's website, it used to be in past days that you could search any regulatory decision or regulatory action, and it was all available. And now it's exceptionally limited what you can access. And then, of course, data also are very difficult to access, even if no one's using them.
One question Jim McPhail asked, and it arose like in the context of Bill, you talking about upstream and downstream effects and pollution levels, is about distance. And Colton, you alluded as well earlier to like Lake Koocanusa in Montana and levels there. Can the three of you comment on like distance? How important is distance? Is this? I mean, should we? There's that imagery of rivers as essentially something that eventually will dilute the pollution to a safe level. I mean, does distance matter here, or does this become a problem that not only affects the regional water system, but then beyond the region as well? Colton, what about Koocanusa? Like, what do we know about levels in Koocanusa?
Yeah, I'll have to digress to Bill, but like in my experience, local impacts are completely acceptable. So if you impact local environments, the populations are small, whether they're ecological or human. So those can be mitigated or managed, whether it's through economics or, it's just the cost of doing business. But when you talk about regional scale impacts, that's different. And Bill, I don't know if that's because legislatively, when you're causing regional impacts, you've triggered a different law or legal system in Alberta. I always found it very interesting that local impacts are completely acceptable and that's just the cost of doing business, but regional aren't.
How about I let Colton say what he wants to say in terms of this lake first?
Sure, yeah, I can add that. I mean, so there's always issues with transboundaries, and like Koocanusa being a transboundary lake, feeding into Montana, they're quite aware of the situation in Teck. So Saskatchewan and even possibly Manitoba will also have their concerns. Saskatchewan, transport of contaminants down to Saskatchewan doesn't seem out of the realm of possibility. I wouldn't expect it to go all the way down to Manitoba. But it depends on the number of mines, the scale of the mines, and how effective they are actually moving forward with their remediation plans and capturing any contaminated or contact water. And I think one thing as well to add to like the first question and build on this as well is coal mining is extremely water intensive, and I'm sure I think this has been talked about in previous town halls as well. They have to process and wash the coal, which requires, I believe, around 1,000 liters of water. So I think it's 250 liters of fresh water on average to about 750 liters of processed water, which is already contaminated, to wash the coal. And then it has to be stored on site. So combining water withdrawals to increasing selenium concentrations and loads in streams and groundwater could, and I mean, yeah, it could impact farther downstream depending on water usage as well.
Mm-hmm. Colton, you mentioned that Montana is going to reduce, and then Bill, hear from you. I just want to follow up with Colton here. So Colton, you mentioned that Montana is reducing what I take is their protection of aquatic life threshold to 0.8, I think was what you said, parts per billion. Is it true that a water body like Koocanusa is probably already over 0.8? Is that the case there? Do you know?
Yeah, so Teck has also been doing water quality management to some degree in the lake, and they have seen concentrations slightly exceeding the water quality guideline of 2 parts per billion. So when you take into account the new law and or water quality guideline in Montana, it's over double. And I think Lars Sander Green and other researchers are also doing independent monitoring of the lake itself. And lakes behave a lot differently than streams. They store chemicals for a much longer time because of the residence time deep within the lakes and the sediments. So having different water quality guidelines between lakes and streams isn't unheard of. And it also depends on legislation and what reports they use to determine, it's called the hazardous concentration for the 5% most susceptible species. And that's how they determine water quality guidelines for different contaminants.
Okay. All right. Thanks, Bill. Over to you on this this.
I'd say how far downstream. Again, I'm not sure. I didn't look at. They also did sequential sampling kind of further downstream in the McLeod River, and there's also, as you know, the Vista mine has since opened also downstream of all of these on them, in that watershed. Mm-hmm. So I don't know. And so I won't hazard that guess. I mean, obviously that's a concern. One thing I will say though is that where there are species like fish that are quite mobile and often use these headwater streams as spawning habitat, they travel throughout the year, and so effectively, fish that aren't present in these local areas may still be affected if they're moving into these systems, feeding, spawning, etc. Whether it's the fish that are feeding and they're getting higher concentrations in their muscle, or if they're spawning and the larvae are, suffering developmental deformities and population crashes because of that or something. There are many other kinds of, whether it's sedimentation or other substantial physical disruptions that go on because of mining. That's big too. Back to what Mandy had said, there's always an effort in these regulatory approval hearings to limit the review to local impacts or project-specific impacts, because when you start talking about regional impacts, it gets into cumulative effects, and that can trigger a bunch of different things or require a bunch of different types of reviews. And so I'd say provincially, the end result is that almost universally in these types of things, they try to stay away from cumulative impacts. The company does, the regulators do, and the governments do, at least pro-development governments do. On the other hand, if you can measure something downstream and potentially point the finger at someone else, well, that's strategy too. So it's hard to say. But that said, this is but one thing on systems that are going to be substantially strained by climate change. And I'm aware of some other work that's been done very recently looking at these coal mine, potential impacts from coal mine on water quality and selenium, combined with what's anticipated for climate change in southern Alberta. And it's got a significant multiplicative effect that has the potential to really exacerbate both the scale and geographic scope of the problem. And especially in southern Alberta, where, if we're relying on downstream dilution to solve the pollution and water, the amount of water is declining long-term. These aren't, week-long operations. These mines will operate potentially for decades if they're making money, but these rock piles are going to be generating contaminants for a very long time. And is this just going to end up being an abandoned, yet another example of abandoned infrastructure that the public has to pay to deal with? I mean, those costs, they make oil and gas infrastructure look like, petty change quite often when it comes to abandoned mines.
Okay. Thank you. One last question that I'm going to put to to the three of you, and in a sense, I flaunt my ignorance about this stuff in asking it, and it's about safe levels of these substances. And Mark Gattell raised it in the context of selenium and ungulates, and so other than aquatic life. And we're seeing here, like Bill, on your slides, you show the protection of aquatic life threshold in Alberta is 2 parts per billion, alert at 1. And then Colton's talking about, well, Montana is reducing their threshold to 0.8. Do we know? I mean, do we, when should I get concerned about selenium? At what level should I be concerned about selenium in water, whether it's for ungulates or for aquatic species or what? I mean, what can you tell me about that, you guys?
You want me to go?
Sure. Well, we'll go.
Okay,
for,
sure.
we'll
There have been lots of studies in the upper McLeod on things like dippers, other birds. Mandy talked about Harlequin ducks, anything that basically eats fish or invertebrates, as well as any mammals that eat fish or invertebrates may suffer consequences because of the bioaccumulation and biomagnification of selenium. You mentioned ungulates. Someone who was a fish and wildlife biologist with Alberta Environment did a master's on exactly that question. What are the impacts of bighorn sheep grazing on these reclaimed mines, which, I mean, they're essentially alfalfa fields on smoothed over coal mines. These are not functional ecosystems. And he found that the whole blood concentrations of selenium in the bighorn sheep on these mines in the Hinton area stand out of all ungulate populations in North America that have been sampled for selenium. They stand out, and they are the only ones that exceed what he kind of identified as a sort of a safe operating level from the perspective of wildlife ungulate populations. So, the aquatics, fish, invertebrates, that's one thing, but selenium is physiologically dangerous to pretty much anything. As Colton said, it's a micronutrient that's necessary, but once it gets too much, then it becomes a toxicant, and there are significant potentials for sublethal or acutely lethal impacts depending on exposure.
Okay, thanks. Colton, what would you echo that, or what's your view on that?
Yeah, I mean, I don't think I can add too much more to that than what Bill said. Yeah, I don't really focus too much on toxicology so much as geochemical processes that control the concentrations in aquatic systems.
Mm-hmm.
So yeah, I think Bill covered it all there for me.
Mandy?
Yeah, I'll just add, I think it's the limitation of the monitoring that's required. We don't do a good job of monitoring for chronic effects or subclinical effects, right? So unless there's a population crash or something overtly toxic where you're seeing deformities in fish or something like that people are noticing, unfortunately, we're not detecting them early enough, if at all. So I think, again, if you dig into some of these reports that I highlighted, you'll see those, the start of declining trends at the population level. But if we had been monitoring subclinical indicators earlier on, we would have detected them. But often, unfortunately, that's in the research environment, right? Within academia and in published reports, often we've detected changes, these subclinical impacts in the environment, but they're all in peer-reviewed publications, and it's really hard to bring that into the industry regulatory reporting. And it's really what we've struggled with in the oil sands monitoring program, right? Peer review publications just not being integrated. The science is great. It's just the integration and how to use it to inform decision making in these monitoring and management programs.
Yeah, I'll point out, at least in terms of the aquatic impacts, there was a recent scientific review that was published that looked at streams downstream of coal mines in the US, and they concluded that on average biodiversity declines by 32% and abundance of organisms declines by 53% downstream of coal mines in the US. And those patterns were consistent, whether it was invertebrates, whether it was fish, or whether it was amphibians. So pretty stark impacts.
Yeah.
I can add another number to that as well. There's been a lot of studies in the US because they have so many coal mines in the Appalachians. And they one study in particular looking at hydrogeology found that when there was more than 2.4% of a given watershed disturbed due to coal mining, they saw large negative impacts in the downstream ecosystems. And so 2.5% of a given watershed isn't very much. It doesn't take much to disturb ecosystems like this.
Yeah. Well, Colton, check out the chat because Willem Langenberg has raised a couple of points to you that I think are that maybe you want to follow up on with respect to the Coal Policy Committee in terms of things you might want to suggest them or submit something to the policy committee. So rather than pose the question, I'll just refer you there and you can check that out. This is the, I don't think any of this is what Minister Nixon had in mind when he said we had a robust system. I mean, you guys are, damn negative thinkers, that's a species at risk in Alberta, or has been in the past. I just want to do a couple things in wrapping up the evening, and those of you at home, stick with us because I get to pitch a concert tonight, so I want you all to hang on until that moment. But on behalf of everyone who has been involved tonight, who's listened tonight, I just want to extend deep thanks to Colton, to Mandy and Bill for taking the time to help us try to understand the issues of toxins and to help us try to understand the regulatory system that purportedly exists to ensure compliance, and when that doesn't happen, to enforce those guidelines. So Mandy, Bill, Colton, just thank you so much for your thoughts this evening. Also behind the scenes to Sean Nichols, who has been supporting us here at AWA, making sure that I get things right in the room that I'm sitting in, or try to get them right anyways. I also, now this is a challenge for me, I have to share my screen, so let's see if this works. I have this, okay, hold shift. No, this is the one I want, share, all right. Okay, this is the one I want though. Why is that not working? See, Sean should be in here, not me. Okay, I hope you can see a thank you notice. Can someone give me a thumbs up if that's there? Okay, excellent. Okay, so it's a pleasant duty to thank the different organizations that AWA has been working with on coal for too long now. The Yellowstone to Yukon Conservation Initiative, Council of Canadians, Livingston Landowners, Extinction Rebellion, CAPE, the Canadian Association of Physicians for the Environment, and the Alberta chapter in the Wildlife Society. I'd just like to thank individuals from all those organizations for the contributions they've made over these past months to try to better understand what's going on in this place when it comes to coal. And the other thing I would like to share is this. So can you see a poster now? Is there a poster there? Something orange anyways? Okay, all right. So let's put the freeze on coal development in Alberta, people. Coalchilla is just about upon us. It's a concert that AWA has put together, bringing together a number of fabulous artists who've been so generous with their time to help us publicize the coal issue in Alberta and to help us raise some money for Livingston landowners and AWA to continue the fight to save our eastern slopes. So this is going to be broadcast over a 1-week period from June 18th through the 25th. Sid Marty, some new guy named Cor Blund, I don't know about him, but you know, apparently he's good and he's spoken quite eloquently. They tell me about coal over the months. John Ward Hannum, Over the Moon, is fabulous duo from Longview. Traveling Mabels, Bradley Bischoff of the Wardens. And I don't know whether Kevin Van Tighem is going to sing or not, but he's going to offer us some thoughts about coal in Alberta. So if you go to the AWA website, you can find a link where you can register for that concert. It's free, but donations are always welcome and encouraged. So with that, everyone, I would like to thank you again for your participation this evening. Wish you all the very best. And let's stop these governments from doing what they seem to intend to do to the eastern slopes of Alberta. So anyways, everyone, good night for now. Take good care of each other. Bye.
Thanks, everyone. Have a good night.
Thanks. Bye.
Thank you.